Hey, this is Mr. Janes. This is part 2 of the Introduction to Right Triangle Trigonometry video. In the last video, we talked about how to find a missing side length if you were given one angle and one side of a right triangle. In this video, we're going to learn how to find the value of the angle theta, so how many degrees that angle is, if we're given two of the sides of a right triangle. And remember, we can use any two sides. In this case, it looks like we've got the adjacent side and the opposite side. Remember, we've got the adjacent side because it is adjacent to this angle theta that we're trying to find, and the opposite side because it is across from or opposite from the angle theta that we're going to try and find. So, to start, we're going to write an equation just like before. Here I've got my adjacent side and my opposite side labeled, so if I remember SOHCAHTOA, I'm going to be using tangent, right? Because SOHCAHTOA, tangent is the trig function that gives me the ratio of the opposite to the adjacent side. So in any case, tangent, now I do not know what this angle is, so I'm going to leave it as the Greek letter or variable, theta, and my opposite side is 7, and my adjacent side is 19. So I'll write tangent of theta equals 7 over 19. Next step is to rewrite the equation with an inverse trig function. But what's an inverse trig function? Functions or inverse operations. For example, the inverse of addition would be subtraction. So if I added 2 to a certain number, I'd have to subtract 2 to bring it back to the original number. If I multiply by 2, then the inverse to that would be dividing by 2. Squaring, well, the inverse of squaring is taking a square root. Now this is not quite the inverse, but we'll save a discussion for that for later. What about sine, cosine, and tangent? Those are functions, or those are operations. Do we have inverses for those? And we do. We have what we call inverse sine, inverse cosine, and inverse tangent. And all they are the same functions, but now they've got this little almost -1 exponent after the abbreviation, but before where we would put the variable. Now we know that if we compose a function with its inverse function, they'll essentially cancel each other out. For example, if I have x times 2, and I use the inverse function divided by 2, then that will just simplify and return x. The same thing will happen with our trigonomic functions. Let's say I've got sine of a variable right here. What I can do is if I compose this with inverse sine, and the inverse sine of sine of x essentially cancels each other out and leaves us with just x. So in order to solve for theta, this variable here, I need to get theta by itself on one side of the equation. That means somehow getting rid of this tangent function. We just talked about using inverse trig functions, so we'll use one here. I'm going to take the inverse tangent of both sides, okay? The inverse tangent of both sides. And so inverse tangent composed with tangent cancels each other out and leaves us with just theta. And on the right-hand side, we're left with the inverse tangent of 7 over 19. We would need a little more background in trigonometry to be able to solve this without a calculator. So what we're going to do is just drop this whole expression, inverse tangent of 7 over 19, into a calculator to find what theta equals. Now you have to be a little careful when you find a calculator to do inverse trig functions with. Take a look at this calculator from Google. We have the regular sine, cosine, and tangent functions that we used in the first video, but notice how there's no little -1 here. So we do not have any inverse trigonomic functions, and we cannot use this calculator. The calculator that comes with most Windows computers can actually help you find inverse trig functions. All you need to do is open it up, make sure you're in scientific calculator mode, and see here we've got sine, cosine, and tangent. Those are our three main trig functions, and you may be tempted to use hyperbolic sine or cosine, but we're not going to use this right now. Instead, simply click the inverse button, and you see now we've got sine inverse, cosine inverse, and tangent inverse. On this calculator, we actually can't type things in like we would on a graphing calculator. We've got to go from the inside out. So we're going to do 7 divided by 19 first. 7 divided by 19. And get our answer there. And then we're going to use inverse tangent. Make sure you're in degrees before you do this. And inverse tangent is about 20.22. So when we round to one decimal place, the nearest tenth they asked for, so 20.2. Theta equals 20.2. And that's 20.2 degrees now, because instead of finding a side, which could be in centimeters or meters or feet, I'm finding an angle, so it's 20.2 degrees. And that sounds about right as far as answers go. If I've got a triangle with a long base here, long adjacent side, and a shorter opposite side, I'm probably going to get an angle around 20 degrees. If you get an answer that's something like 135 degrees, that's too big. It's not going to work. Or an answer like 0.001, again, that doesn't make sense as an angle. But in this case, 20.2 does. If you've got access to the internet, you can actually use Desmos, which is one of my favorite graphing calculators to do trig functions with. All you've got to do is go to desmos.com, open up a new graph, and go to Functions, and we're going to select arctangent here. Arctangent is another name for inverse tangent. They mean the same thing. Either it's tangent to the -1 or written arctangent. So arctangent, and we need arctangent or inverse tangent of 7/19. And, I get 0.35. Wait a second. I don't think I'm in degrees. So let me go over to the tools, the graph settings, put myself, radians, put myself in degrees, and there we go. My answer is 20.22 degrees. Again, if you got internet access, this is a much easier tool to use than maybe the Windows calculator or Google calculator, desmos.com. At this point, I'd like you to go ahead and try and answer these last two questions here. Find the angle theta in each, show your equations, and round to the nearest tenth. Please pause the video now. The answers will be coming up in 3, 2, and here we are. In the first triangle, we're given the adjacent and the hypotenuse, and so we're going to use cosine here. We have cosine of theta equals 9/13 because cosine equals adjacent over hypotenuse. To get theta by itself and to figure out the value of that angle, we'll use inverse cosine on both sides of the equation, and we'll be left with that theta is equal to the inverse cosine, also called arc cosine, of 9/13. Let's hop back to Desmos to help us calculate this. Let's make sure we're in degree mode. We are. And let's use, now we have to use inverse cosine, also called arc cosine. So arc cosine of 9/13 gives us 46.18, so let's call that 46.2 degrees. So theta equals 46.2 degrees. Again, a reasonable answer. In the second example, we're going to use sine because we have the opposite side to the angle theta right here, and the hypotenuse, the longest side, across from what looks to be the right angle. So sine of theta equals 17/22. Just like before, we use inverse sine to get theta by itself, and so we're left with inverse sine of 17/22. And so inverse sine, also called arc sine, of 17/22 leaves us with 50.599. We'll call that 50.6 degrees, with theta equaling 50.6 degrees. Now that makes sense to me because we've got a larger opposite side in comparison to our hypotenuse, and so it looks like it's probably going to be larger than 45 degrees, but not that much, so about 50 degrees makes sense. In order to gain a better understanding of trigonometry, we're going to take a look at these 6 discussion questions. What I'd like you to do is take a look at these 6 of these and see if you can answer them, or at least think about them and jot down as much as you can. As a little bit of a hint, the first 5 ask you to analyze an equation, such as tangent of theta equals 5/5 or cosine of theta equals square root of 3/2. To help us see these a little more clearly without just looking at an equation, I strongly suggest you draw out a right triangle and pick an angle to label as theta, such as this one right here, and go ahead and label the sides as the equation instructs you to. So tangent of theta is 5/5. Remember SOHCAHTOA, SOHCAHTOA. I remember that tangent is the ratio of the opposite to adjacent side. My opposite side is right here. My adjacent side is here. So tangent of theta is 5 for the opposite side. And my adjacent side will be proportional to 5. And so you can use a diagram like this for the first 5 questions here to help you answer each of these discussion questions. Pause the video now. The answers are coming up in 3, 2, 1. Triangle here that we've already drawn with sides 5 and 5. And so when I ask the question, is theta more than 45 degrees, less than 45 degrees, or exactly 45 degrees, I can notice that this triangle is actually an isosceles triangle, because those are both congruent sides. And as a result, the base angles, these two here, will be congruent, and since it's an isosceles right triangle, those two angles are exactly 45 degrees. This is a 45, 45, 90 triangle. So theta is exactly 45 degrees. And we could tell that just by analyzing this equation here. Of course, we could have put this in the calculator. Maybe use inverse tangent to figure this out, but we don't even need to do that. Just by drawing the triangle, we can simply see that this must be an isosceles right triangle, and that theta is 45 degrees. For number 2, we can do a similar thing. Go ahead and draw a triangle, call this theta, and we have tangent of theta is 6 over 10. Now tangent again is opposite over adjacent, so here's my opposite, it's proportional to 6. My adjacent is proportional to 10, and well, maybe that's not the best drawing. If I drew this more to scale, we notice that our adjacent side, 10, is much longer than our opposite side, 6. And so this angle here has got to be less than 45 degrees. Theta is less than 45 degrees. Again, because my opposite side is smaller or shorter than my adjacent side. We could have gone ahead and solved this equation with the calculator, but there's no need to do that. Just drawing out the triangle helps us see that theta's got to be less than 45 degrees. For number 3, go ahead and draw our triangle. We've got tangent of 8 over 3, so I will label my opposite side with 8, my adjacent side with 3, and this is a little bit different. In this case, it seems like my opposite side is larger than my adjacent side, and so this angle is seemingly going to be greater than 45 degrees. So theta is greater than 45 degrees. Again, we could have used the calculator, but there's no need. Just drawing out the triangle and using these trig ratios is quite enough. Number 3, it's a little bit different. We'll start the same by drawing out our triangle. It says sine of theta equals 10 over 4. Sine, remember, is opposite over hypotenuse. So the opposite side here will be 10. My hypotenuse will be 4. Is this equation possible? Why or why not? Well, look at this triangle. My hypotenuse right here is 4, and my opposite side is 10. Can hypotenuse ever be longer than any of the other sides? No, by definition, the hypotenuse is the longest side. So this equation is impossible because it implies that the hypotenuse is smaller than the opposite side, which we know is not true for a right triangle. Again, 5 is a little bit different, but we'll start the same way. We'll draw a triangle. Let's call this theta. There's our right angle. Cosine of theta. Now cosine is adjacent over hypotenuse, so square root of 3 and 2 goes there. Can you determine what theta is? So we're asking for an exact value here. Well, this triangle actually looks a little familiar to me. This triangle looks a lot like a 30, 60, 90 triangle with sides square root of 3, 2, and 1. And in fact, if I use Pythagorean theorem to finish this, that's what I would get. 1, 2, square root of 3. And in a 30, 60, 90 triangle, I know that the angle across from the square root of 3 is a 60-degree angle, and the angle across from the one side is a 30-degree angle. So that must mean, since this is proportional to a 30, 60, 90 triangle, that theta is going to be 30 degrees. This is a skill you use much more often in a class like trigonometry or pre-calculus, but it's nice to see how this starts to work now. Lastly, do you think there are other possible trigonometric ratios that use the hypotenuse, opposite, and adjacent sides besides sine, cosine, and tangent? Well, in fact, there are. Is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We also have something called cosecant, which is hypotenuse over opposite, secant, which is hypotenuse over adjacent, and cotangent, which is adjacent over opposite. Now you won't see these or need to know anything about them until you take a trigonometry or pre-calc class, so don't worry about them for now. Just, it might be nice to know that there are 3 other functions out there that you can use besides sine, cosine, and tangent. I hope these questions have given you something to think about as we start to learn trigonometry. If you have any other issues, make sure you come see me or drop me an email. Good luck!